Hello guys and welcome back to my channel Interview with Bunny, and today we are back with another video on system designing, and the application of the system that we will be designing today is a ticket booking system like BookMyShow, Paytm or District. So basically it is an online service that allow users to book ticket for a movie, event or some concert. So this is basically our problem statement. So let's see how we will design this system. So as I've told you in my last video, system design questions are very much open-ended. Means your interviewer will just give you a problem statement like design a ticket booking application, and it is totally your responsibility to discuss with your interviewer and get the actual function and the non-functional requirement of the system that you have to design. So without wasting much time, let's start with our first step of system designing, and that is gathering of the requirement. And the first requirements that we have to gather is the functional requirement. So let's see what can be the functional requirement of this system. So the functional requirement of this system is very straightforward, because you know in a ticket booking application you only have a couple of steps or a couple of events that you have to perform to book a ticket for any movie or for any event, and those steps or the events become the requirement of our system. So let's see what can be the requirement over here. So the first and the foremost requirement is whenever a user lands to our application, the user should be able to search a particular event, movie or any concert based on some keyword, search location or based on some date. So that should be our first functional requirement. Now the next requirement would be once he finds a particular event based on that preferences, the user should be able to see the detail of the event or the movie, means who is performing the event or what is the movie all about. All those metadata should be present on the screen. And once the user is on the event screen, the next step is like the user should be able to book the ticket, and that is the final step of our requirement. So over here we have primarily three most important functional requirements, that is searching an event, viewing an event, and number 3, booking the ticket for an event. So here when I am talking about an event, it can be any movie, a comedy show, or it can be any concert. So this should be our functional requirement. So without wasting much time, let's list down all the functional requirement over here. So here as you see, this will be the 3 functional requirement of our system. This is quite straightforward. Now let's see what can be the non-functional requirement for the system. And when we tell the non-functional requirement, we means the characteristics of the system. Means whether the system should be highly reliable, consistent, and all those characters. So as I have already told you in my last video, the first non-functional requirement that you have to discuss is the scale of the system. Means the total number of users for which you are designing the system. Because based on that count, there are lots of critical decisions that you have to take to make your system highly reliable and consistent. So let's see what can be the scale of the system. So if you ask this question to your interviewer that what would be the scale of the system, he will be giving you some ballpark number so that you can make some estimation out of that. So let's assume that we are making this system for 100 million active users. So here you can see this is a huge amount of traffic that we are discussing over here. So let's write down the scale of the system, that would be 100 million daily active users. Now the next most important non-functional requirement is the cap theorem. And what cap theorem tells that? That is, whenever you are designing a microservice, means a distributed service, you have to compromise between the availability of the system or with the consistency of the system. Means it should be either highly available or it should be highly consistent. But you cannot achieve both of them together in a particular part of the system. So that is called the cap theorem. So let's see over here how we will explain the cap theorem for this designing. So though cap theorem tells that we cannot have both high availability and the consistency in a particular system, but if you look carefully in our application, we need both of them, because obviously our application should be highly available, otherwise user won't be able to book a particular ticket, And also our application should be highly consistent because it is a ticket booking application. Means no two users should be able to book a particular seat for a particular event. So here the system should be also highly consistent. Then what should we do? So here we have to explain to the user that which part of your application you want to make consistent and which part of your application you want to make available. So here if you understand it correctly, our application should be highly available with respect to the search and viewing the event. Means whenever a user lands to your application, the application should be up and running, and also whenever he is trying to search for a movie or search for an event, the resultant set should come up very quickly. So on those lines, your system should be highly available. But also when the user is trying to make a booking, means select a seat and confirm the booking, at that time on the booking section, your system should be highly consistent. So here write down the requirement clearly that your system should be highly available with respect to search and viewing the event, and your system should be highly consistent for booking an event. So do not forget to write all these things clearly during your interview so that it leaves a prominent impact to your interviewer. So let's write down over here. So these are more or less the non-functional requirement of the system. So now since we have gathered both the functional and the non-functional requirement for our systems, which means that we are done with the first step of our designing. Now let's move to the second step of our designing, and that is the identification of the core entity. So the core entity of these services are quite straightforward. What can be the core entity? Number 1 is the user. Number 2 is the event, means the movie or the concert. Number 3 is the venue or the movie hall that you want to visit. And number 4 is the ticket that you want to book. So here there are 4 core entities in our system. So let's write down all the core entities that you can identify as of now. Maybe it will change in the future while we will be designing, but as of now, based on the functional requirements and the non-functional requirement that you have gathered, you can only identify the 4 core entities over here. So let's list down all of this. So this will be our core entity. Now we will move to the next step of our system designing, and the third step, and that is API creation. So as I have already told you, API creation is quite easy if you have listed down the functional requirement properly, because more or less it will be a one-on-one mapping of the functional requirement and the APIs that you have to design. So let's see what will be the APIs or the REST endpoint that you have to design to fulfill all the functional requirements. So the next step is API design. So the first endpoint that you have to provide over here is to fulfill the requirement of searchability. Means your user should be able to search a particular event based on some title, location, and the date. So here we will be designing the first endpoint, and that is for searching a particular event. And obviously since here we are searching an event, means we will be getting some output from our REST API. So obviously it will be a GET API. So let's design the GET API over here. So here you can see this will be our search API, and in the API, means in the search criteria, you can pass couple of attributes. Means you can pass the name of the event or the location and the date. So here how we will represent it, it is like this. So over here you can search with any search term, means it can be any free text that you want to provide. The next searching condition can be the location. So obviously you can make a search using the location. So this location can be a latitude or longitude, and the next criteria will be the date of the event. So there will be one more search criteria, and that is with date. So more or less this will be the criteria by which you can search. Discuss this with your interviewer to get a clear understanding that on what are the other attributes a user should be able to search a particular event, and based on that modify this search criteria over here. I think this is clear. And what it should return? It should ideally return us a list of matching events. So over here I will write the response as list of event IDs. So how it is happening? Whenever a user is trying to search based on some keywords, location or with some date, our application is going into the database, searching in the database, and based on the search result, it will give back all the event ID that are relevant to this search criteria. It might can happen that there are more than one event that matches our search criteria, and that is why here I have returned a list rather than a particular event. And along with this event ID, if you want, you can also send some additional metadata of the event like the title, the small thumbnail, or the event description in a short, so that you can create a search result page over there. And remember, if the search result is quite huge over here, you have to return in the form of pagination. So it will be in the form of pagination. So here we are done with the first endpoint that is required to fulfill the first functional requirement, and that is this one. So here we are done with the first endpoint. Let's go to the next endpoint, and that is user should be able to view the details of a particular event. So over here, if you see the event list that I'm getting from the previous search result, based on the event list, whenever a user is selecting a particular event, he should be able to see the entire metadata of an event or the movie. Means what is the title of the movie, who all are the director, actors, what is the movie all about, and all the description as well as the seat booking layout, means what are the available seats. So all those metadata should come up when you are clicking up event. So this is how our second endpoint will look like. So here if you see, we are having an endpoint called as event, where you are passing the event ID which we are receiving from our previous search result, and here this API endpoint return us a couple of things, that is the event details, means the metadata of the event, the location where it is happening, and also the list of all the tickets that are available for that venue or for that movie hall. So this will give you a complete detail or the complete picture of a particular movie. And once the user get all those details, then the next step is booking the movie, which is our third functional requirement over here. And here, since we are submitting a request, obviously this should not be a GET call, rather it will be a POST call. And if you look carefully, this booking is a two-step process. Means first you book a particular seat, and after that you make the payment for that. And once this two-step process gets completed, only then a particular seats gets allocated to your name. So though here we are having a single requirement, but this is actually a two-step process. And since this is a post call, so obviously we have to send some body in our post call. And what is the data that we have to send over here? The data that is required is the seat ID or the ticket ID that our user is trying to book. Over here, I will just make a small modification, that is here, instead of naming it as tickets, let's name it as seats. Means it will list down all the seats that are available for a particular event rather than calling it a ticket, so that it will be clear for you to understand. So let's name it as seats. And here in the body of the request, we have to send all the list of seats that the user want to book. So obviously it might can happen that in a particular request, he want to book more than one seat. So here also we have to send a list of seats in our post call. So this will be the body of our reserve call. Now one thing, if you have noticed, I have not implicitly mentioned the user ID of this user, because obviously the user ID is necessary to book a particular ticket. Otherwise we cannot map the user ID with the list of tickets that he or she have booked. But here, instead of sending the user ID within the body of the request, it is better to send the user ID of the user in the header of the request, so that it will be a secure API call. So do not forget to mention this to your interviewer. So this will be our first call, and that is the reserve call. And once the seat is reserved, then what we have to do? We have to make the payment to confirm it. So that will be another call, and that is the confirm call. And here what we will be passing? So it will be the booking ID and the payment details. And from where we will get the booking ID? So here the first request that you are making over here means in the reserve call, this reserve API will send you a booking ID, and based on that booking ID, you have to make the final payment over here. And that is why here you are passing the booking ID and all the payment details that are required for making any payment. So I hope we are done with our API creation over here. So here if you look carefully, we are done with the the third step of the designing, and that is the API creation. Now let's move to the next thing, and that is the high level designing of the system, where we will be drawing some arbitrary box and we will be trying to fulfill all the functional requirements that we have gathered from our interviewer, and we will try to design and solve the problem. So let's start with the fourth step, and that is the high level designing of our ticket booking application. So as you know, high level designing is very easy to do if you have managed to fulfill till this point. Because designing a high level means you just have to convert this functional requirement into a pictorial view with the help of some service and server. So let's see how we can do it over here. So the first component obviously that is required to create a ticket booking application is the client or the user. So let's design the first thing, and that is the client over here. So these are our clients, and if you look carefully in our non-functional requirement, we are actually targeting 100 million daily active user. And based on this huge number, you can easily guess that we have to go with a microservice architecture rather than a monolithic architecture. Because as you know, monolithic service means we have to write down all the codes, logic and everything in a single service, and your server have to handle all this huge amount of load all alone, which is obviously not possible because a monolithic server cannot be scaled properly using the vertical scaling approach. So what we will do, we will be going with a microservice architecture, and there with the help of the horizontal scaling, we will try to handle this amount of traffic for our system. So over here we are clear that we are going with a microservice architecture, and whenever you are telling that we are going with a microservice architecture, so obviously when you are designing a high level design of your system, you have to introduce a load balancer, or you have to use an API gateway to handle all the huge amount of traffic. So here what we will do, we will introduce an API gateway to accept all the huge amount of traffic from our user. So here this will be our API gateway, and the main functionality of the API gateway will be authentication and authorization, rate limiting and routing the request to the proper microservices application. So let's write down all those things over here. Now the next step is we have to design some server. So as a high level designing, we will just make it simple, and we will write a simple server like a backend server over here. Maybe we will simply name it as a booking service. So what is happening over here? Our clients are making the API calls into our server, and using our load balancer and using our API gateway, our entire traffic is getting distributed into our booking service. And in our booking service, what we are doing, we are performing all these stuffs that we have discussed over here. Means we are making a search call, we are viewing an event, and we are booking a particular movie. And once the booking is finally confirmed and made, obviously we have to update in a database. So over here also we need a database where all the details of the movie and the booking will be present. So here you can see this is quite a high level designing that we have done over here. Means here we are having a server which is responsible for everything. Means whenever a user is making an API call, the request is coming into our server. The server is looking into the database, searching all the events based on the search criteria, and from here it is returning the search result to the user. And once the user is fine with the particular event, he will make a payment and do our booking over here. But if you have understood it correctly, there are lots of responsibility that we have given to this single server, and obviously your single server will not be able to handle all this functionality all alone. So what we have to do, we have to divide this functionality into different servers so that each and every server can handle their own functionality separately, so that our system would scale and function properly. So the first thing that we have to do over here is we have to break down this booking service into different components. And if you have understood it correctly, we primarily need three components. One is for searching, another for retrieving all the metadata of the events, and number three is for for booking a particular event or booking a particular movie ticket. So here what we'll do, I will divide this entire booking service into three components over here. So here I have divided this entire system into three components. One is the search component, another is the event service, and another is the booking service. So here we have achieved the separation of concern, means a particular individual application will be only responsible for performing a separate task. So here as you see, whenever a user sends a request to our server based on our API endpoints, our API gateway will distribute the traffic accordingly. Means all the search requests will go to the search service, all the event related requests will go to the event service, and all the booking related queries will go into the booking service. And obviously internally this search service will talk to this database to retrieve all the result for a particular search. Similarly, our event service will talk to this database to get all the metadata, and similarly our booking service will talk to a database to confirm a particular booking. So more or less this is overall the high level designing of our entire system. Now since we have designed the entire high level and we abstractly know that what each and every component is doing over here, let's now go into the deep dive analysis, and that is the low level designing of our system, where we will see in detail that what and how this search functionality will work, means from this huge amount of database how it will make a particular search in the most efficient and in most optimized time. Also we will see that how this event service will manage to retrieve all the data from the database, and also here we will see that how this booking service will be used for managing a particular booking. Because remember, here in the booking service we have to handle concurrent booking, because maybe thousands of user is trying to book for a particular seat, and there we have to design a system in such a way that there should be no error and the booking should be consistent, and only a single user will get the confirmation for that booking. So all those detailed implementation we will see in our next step, and that is in the low level designing, where we will be designing each and every service in much more detail. So let's move to the next step of our system designing, and that is the low level designing. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So first what I will do, I will copy this entire design from here and I will paste it in our low level section so that we can enhance each and every component over here. So the first thing that I want to talk about is the database structure. So over here, if you see, I have given a vague idea that we just need a database to save all the metadata of the events. But here we have to specify it clearly that what is the database that we want to use over here and what will be the schema structure and the attribute that will be stored in our database. So let's see in detail. So here if you look carefully, the data that we are persisting in our DB are of two types. Number one is the data about the bookings of the customer, and number two, the metadata of all the events, the movies and the concert that are happening. And if you try to understand the volume of our system or the scale of our system, you would see that the total amount of the metadata that we have in our system, means that information about the movies, the events and all these things is quite huge. And over that huge set of data, we have to apply our search logic so that the user gets the relevant information, whatever he is looking for. So that is one part of our database. And the next part is the booking information. Means, for example, I want to book an event there once I make a payment, all my metadata, the payment history, the booking information, the seat information should be saved in the database. And if you try to understand a basic fundamental, here you will see all the booking or the payment related information should be consistent. Means no two users should be allowed to book a single seat for a particular event. So there we have to maintain the consistency in our database. And whenever we are telling that we have to make the consistency in a database, blindly go for a MySQL or a Postgres database. Now let's see in what type of database we have to save the data related to the events and the movies. So for storing the event related data, means the metadata of the movies, the actors, the event, all those things, you can go with a NoSQL database, and over here the best solution will be a Cassandra DB, because with respect to the CAP theorem, Cassandra database show the characteristics of high availability. So we would go with the Cassandra database over here, where we can store all the metadata of a particular event. So over here, to keep the metadata of the events, we will go with the Cassandra DB. I hope this is clear, because if you remember when we are discussing the CAP theorem over here, we were telling that we need the high availability with respect to searching and viewing of the event. And do remember, whenever we have a problem statement, something like this, always go for a Cassandra DB, because Cassandra show the characteristics of high availability. So over here also, to save all the metadata, we are going with the Cassandra database. Now let's talk about what are the data that will be there in the DB. So here we can store a lot of metadata for a particular event. So for example, there will be an event table which will be having an event ID, event venue, the performer or the artist ID, the name, description, the seat, and all those information can be there in this event DB. Similarly, over here we will be having data about the movie, which will be more or less similar. That is name of the movie, description of the movie, like movie ID, name of the actors, the seat allocation, venue, and all those things. So all those metadata of any event or any movie can be easily stored in this Cassandra database. So let's list down all those things over here. So in this way, you have to persist all those event related details in this Cassandra DB. So now comes the main thing, that is the searching logic that we have implemented. So over here, if you see what we have to do, whenever a user is trying to search for a movie title, what will happen is like the request will come to our API gateway, and from API gateway it will get routed to our search engine, that is this one, and from here, based on the title of the movie or whatever the search criteria that the user have given, we have to search that detail from our database, which is actually a huge database, since over here we are saving a tons of metadata of the user. And if you see the characteristic of the Cassandra database is write heavy, means it is very much write optimized, but it is not a read optimized data. So by anyhow, if we save all the metadata of our events and the movies in the Cassandra, it is not possible to scrap all the data and search it from there in a very optimized time. So what we have to do, we somehow have to optimize this search engine so that the latency of the search becomes minimum. And do remember, in our system designing, whenever our interviewer is asking for a system where the searching should be highly optimized, blindly go for a Elasticsearch, because Elasticsearch is highly optimized for the searching, and we should definitely go for a Elasticsearch over here also. So our search engine will internally call the Elasticsearch so that our user can search anything in a very optimized way. But the question is how the data will come from this Cassandra database to our Elasticsearch. So for that, what we have to do, we have to write some ingestion job by which we can transfer the data from the Cassandra to the Elasticsearch. So here you can see, though we are having same data as duplicate both in the Cassandra as well as in the Elasticsearch, but here to support all the functionalities as per our requirement, we have to go with this approach. That is, whatever the metadata of the event need to be persistent, that should be within this Cassandra database. And whenever we are trying to search over that millions of data, then we have to go for the Elasticsearch. And to ingest the data within the Elasticsearch, we have to write a cron job or something to feed all this metadata into our Elasticsearch, because the choice of database that we have taken over here, that is Cassandra, is not optimized for searching. So keep this thing in mind. But here the question might arise, then why we are going for a Cassandra database? Why we are not going for a MySQL or any simple database? The reason, because if we are saving those millions of record in a MySQL database, there also we have to go with some partitioning and indexing on the data. And in that case, if we are saving our data in a Postgres or a MySQL, there we have to go with partitioning or indexing. And where we can put the indexing? We can put the indexing maybe on the title. But here if you see, here the user have the flexibility to search based on title, date, location. It can be anything. We are not sure about what the user will be searching with. So multiple indexing is not possible, or it is not optimized for a Postgres database. That is why what we have to do, whenever there is a question of searching, blindly go with an Elasticsearch. Now let's see how we will ingest the data from this Cassandra into our Elasticsearch. So the way we will be doing it, we will be using a ingester service, or we will be create a CDC pipeline. So let me write it over here. After that, I will tell you what is this thing and how you should implement. So over here, we have to write a logic that is called as CDC. And the full form of that is change data capture. So let's see what does it mean and how we can implement a CDC over here. So the CDC, or the change data capture, means that whenever there is a change in this Cassandra database, a change event will get triggered, and whatever the change event that triggers from here, that will get automatically ingested into our Elasticsearch, so that all the real-time data from here should be available for the user to make any search. Now let me tell you what can be the real-time data that will change. So if you look carefully into our architecture, whenever a user is trying to search for a movie or an event, it will simply search via this pipeline. Means the request will go into our search microservice, and from there it will call our Elasticsearch to give us the result. So this flow is fine. Now if you see the event data or the movie data that we are sending by the Elasticsearch consists of few real-time attributes. That is, over here you can see there is an attribute called as seats. Means whatever the availability of the seats for this event will be captured over here. So for example, for a particular movie, there are 20 seats that are remaining. So when the user search for that movie, that metadata will go to the user that for that movie 20 seats are still vacant. Now what he will do, after selecting a particular seat, he will go for the booking service, and once the payment and the booking is confirmed, then what we have to do, we have to do two things. One, we have to save the metadata of the booking into this database, that is our Postgres database, which will have all the payment related information and the order history. And also we have to decrease one seat for that user. Means from this booking microservices, we have to make another call within this Cassandra database to allocate a particular seat for that user. So for example, initially there were 20 seats that are remaining, but after the booking has been confirmed, there are 19 seats that are remaining. So we have to update that thing using our booking service. And here if you see, we have choose the Cassandra database, which is highly write optimized. So whenever there is a small change, means a seat is getting updated, Cassandra database will persist it very quickly and efficiently. And whenever the detail of the seats, that is the small metadata that got changed over here, a CDC event will get generated from here, and the new updated record will get fed into this Elasticsearch. Means right now, once the second user is searching for the same movie, he will see that right now 19 seats are vacant, not the 20. So over here you see how first with this architecture we are capturing each and every event, so that in real time the next user can see all the changes that are happening. I hope this is clear. Now how this CDC is implemented, believe me, this is itself a huge implementation of how to create a CDC pipeline, which I will be also creating the entire design structure very quickly. But just to give you a heads up that how CDC work is like, here we have the Cassandra DB. From this Cassandra DB, we will be plugging a software called as Debezium. and that Debezium will capture all the small changes into a system, and it will push all those small changes into a streaming service, that is a Kafka service. And from that Kafka service, we have to write another ingestion job to ingest the data into our Elasticsearch application. So this is actually a 2 or 3 step process how this CDC service works. But over here, since this is not the main application that we are designing, so we will keep it abstract. Just we will mention this, that we will be using a CDC technology to capture all those metadata that are getting changes, and we will be ingesting it to our Elastic service. That is the only thing that you have to do during your technical interview. Now let's move to the most critical service, and that is the booking service. Let's see how this booking service will work and how this booking service will maintain the consistency in the database, and how we should design it so that no two user gets a same set. So let's first understand what can be the scenario in the booking service. So for example, once the user search a particular event or a movie, all the available seats will be shown to his screen. Now it might happen that two users are trying to book the same seat at a particular time, but we have to design our system in such a way that only a single person among those two should be successfully able to book the seat. So let me tell you how we will do it. So for example, for a particular movie theater, let's assume that two users are trying to book for the Spider-Man movie, and here both the users are trying to book the same seat, that is L12 and L13. Now what will happen that the request will first come to our server, and once it reaches the booking server, what we have to do, we have to first check whether the seat is available or not. And for that, what we can do, we can go with two approaches. Number one, once the request come to your booking service, we will first see that whether the seat is empty or not. And if we check that the seat is empty, we have to first reserve that seat, because as I have told you, booking a seat is a two-step process. Means we have to first reserve the seat, and after that we have to make the payment to confirm that seat for that particular user. So over here you can see there is a small delay between these two actions. Once you have to reserve, and after that, that reserve call will go to our payment gateway, and from there, once the payment is done successfully, then the seat will be booked. So let's take an example. Here we have two users, that is user 1 and user 2, and the request for the user 2 came before user 1. So what we'll do, as soon as we see that both the L12 and L13 is vacant, we will simply reserve that seat for the user 2 for 5 to 10 minutes till he is done with the payment. And after that, once the request for the user once comes into our booking service, we will again check what is the status of the seat. And here if you see, the seats over here are in reserve status. Means that this seat have been booked, or we have to show it with a gray icon or something. Now over here, let's take two scenarios. Number one, the user 2 made a payment, and number 2, he didn't make a payment. So in the first case where he have made the payment, what will happen is like, our booking service will call another service, that is our payment gateway. So let's design one more service, that is the payment gateway. Now once the payment is successful, the acknowledgement request will come again to the booking service. And once the booking service will see that the payment is successful for the user 2 for the seat L12 and L30, then what it will do, it will change status of the seat in the Cassandra database from reserved to booked or occupied. Means the ticket had been confirmed. But in the second case, for example, the user didn't make the payment, or maybe for some other reason, the user left our system, what will happen to that seat? That seat will become reserved forever. So what we can do to solve this problem, here we can write a simple cron job which will keep on checking each and every minute into our Cassandra database that which of the seats are in reserve status, and whether that reserve states have passed the 5-minute or the 10-minute timestamp or not. Because here we are giving a provision to reserve a particular seat for maybe 10 minutes. So here, if the 10 minutes had been crossed and the user have not made the payment, we have to change the status of the seat from reserved to available. So that will be the flow of the application. But here, if you understand it correctly, this is actually a very complex thing that we are introducing, because here the cron job have to run each and every minute, and it have to parse all the data that are available in our database, and it have to keep on updating each and every seat over there, which is actually not a good solution. So let's see what can be the other approach. So I hope you have understand this flow correctly. So the flow is, once a user tries to book a particular ticket, we are first checking our Cassandra database that whether the seat is available or not. If it is available, we are making it reserved for 10 minutes and we are redirecting the user to the payment gateway. And within that 10 minutes, if the user successfully made the payment, then we have to again change the status of that reserved seat to confirm. And otherwise, if the payment fails by anyhow or the user didn't make the payment, then what we have to do, we have to write a cron job that will run every minute, and it will parse all the seats in our database and it will check that whether the seat is in reserve status or not. And if the seat is in reserve status, whether the reserve time have exceeded the 10 minutes window or not. And if it had exceeded the 10-minute window, then we have to change the status of the seat from reserved to available again for booking. But if you see, this is actually not a good approach to implement this, because this solution is not real time, not consistent, and not a reliable solution. So let's see what can be the other approach by which we can solve this problem. So the other approach by which we can solve this problem is, first we will get rid of this cron job. Now the next thing that we will do, over here we will introduce a Redis cluster. Why we are introducing? I will tell you very soon. So over here we have introduced a Redis cluster. Now what happens is like, so for example, the user 1 is trying to book a particular ticket, maybe seat L12 and 13. So what happens that the request will come to our booking service. We will first check whether it is present on the Redis or not. And if it is not present in our Redis cluster, we will understand that no other user is trying to book that ticket. Then what we'll do, we will simply store this information in our Redis cluster, and here we will set a timer, that is a TTL, and we will set the TTL to 10 minutes, and thereafter a redirect call will go to the payment service, and if the user confirms the payment, means do the payment successfully, we will remove this entry from the Redis server and we will simply update this MySQL or the PostgreSDB that the payment has been done successfully, and we will update this Cassandra database that this seat has been reserved. And from there what will happen, once we update the seat status, this CDC pipeline will take place, and thereafter other user will see that this seat is not available any further. Now let's take the example that if the payment fails over here. So if the payment fails over here, what will happen is like after 10 minutes, means after this TTL time, this record will get deleted automatically from the Redis cluster. Means here we do not need to explicitly write a cron job to remove it, and thus once the second user is trying to book the same ticket, it will check that the seat are not present in our Redis cluster, means no user is trying to book that seat, and thus it will go to the payment gateway for confirmation. So this is how this booking flow will work. So I hope we are pretty much done with each and every requirement that we have gathered. So let's go back to each and every requirement that we have taken at the very beginning, and let's see whether we have done it successfully or not. So here if you see, we have our first functional requirement, that is the user should be able to search based on title, location and date. And you can see for that we have provision for the elastic search where the user can search anything based on his requirement. Next, the user should be able to view the details of the event, that is the seat details and everything, which we have already captured in our Cassandra database, which obviously we are sending it in the near real time using this CDC pipeline. Next is the user should be able to book a particular seat for the event. And for that you can see we have the booking service where we are having a Redis cluster to manage all the concurrent booking, and once the booking is confirmed, then we are persisting those data into this Cassandra database as well as in this payment database. And regarding the non-functional requirement, you can easily see here our requirement was we have to scale for the 100 million active user. So obviously since this is a microservice architecture, so based on the requirement you can easily scale up your pods based on your needs. So for example over here if you just analyze, this is a ticket booking service, and over here the read request is more than the write request, means the total number of users who are viewing the event or searching for the event are more than the total number of persons who are actually actually booking the ticket. So you can easily understand that since here the rate of the read request is more than the write request, so what we have to do, we have to scale this search service more than that of this booking service. So obviously based on the requirement, we have to scale it properly. Similarly, we will be having the event service also scaled up based on our use case. Now the next non-functional requirement was our cap theorem, that is the system should be highly available for viewing and searching of the event, and it should be highly consistent for booking service. So here also you can see we have made our service highly available by introducing the Cassandra over here, and we have made it highly consistent by introducing this Redis cluster and the Postgres or the MySQL database over here. Now since we are at the end of the designing, let me tell you one more important thing. Let's take an example that you have managed to complete this entire system designing within 40 minutes or so, and your interviewer might have some more time to ask few more questions regarding this designing as a follow-up question. So let me tell you what can be the next follow-up question for this designing. So the next follow-up question is, how will you handle a peak in the traffic? So for example, our BookMyShow is hosting a ticket for an international concert. For example, Coldplay is coming or something of that hype. Now at that time, how you will handle that huge amount of traffic into our system? That can be a good follow-up question for this designing. So let's see how we can solve that problem. If you have remember, when we were booking a ticket for the Coldplay or anything, there once we are trying to book the ticket, we were kept in a waiting queue, and once our number comes from the waiting queue, then only we have to make the payment and confirm our booking. So if you guessed it right, what we have to do for those type of events where there is a huge traffic or a huge peak that you can estimate, there what you have to do, there you have to introduce a waiting queue over here. So for example, here we have to go for a Kafka service which will act as our waiting queue. So for example, whenever you are booking for an event like Coldplay or something where there's a huge peak in booking service, there instead of directly hitting the booking service, all the user will be kept in the Kafka over here, and once the number for that particular user comes, then what will happen? That user will go to the booking service and thereafter he will make the payment and confirm the booking. And with this designing, you can easily handle a sudden surge or sudden peak in traffic on your booking service. So hopefully you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So see you on our next video where we will be solving another system designing problem. So see you on our next video. Thank you.